Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. In this video, we're talking about this independent versus dependent variables homework. And so it says match the independent variables listed below with their corresponding dependent variables by drawing a line to connect them. So again, you could draw the line so that way you make the pairs, or you could also write, 1, 2, 3, 4, so on and so forth, or A, B, C, D. That way it's not as messy. So for example, the first one is done for you. The length of your foot is the independent variable, which means your shoe size relies on or depends on the length of your foot. So we would say, all right, we match the first one with the shoe size. Then you could say the minutes used would affect the cell phone bill, the number of songs on your device would affect the amount of memory on your device. How fast you drive will affect how long or the time it takes you to get somewhere. The age of your child is going to affect the height of your child, and the amount of money you make is going to rely on or depend on the amount of hours you work. So again, always make sure you're saying the independent variable is that X value, and that's the one that you're putting into the dependent variable. So you're going to get that result. On number 1, it says Letitia works at a hair salon and receives an hourly wage of $7.50, not including tips. She generally makes $30 in tips a day. If P represents her total pay and H represents the amount of hours she works, then P equals 7.5 times H plus 30 is an equation that represents her pay each day. So again, we're using this as the equation, so it's already given to you. And you can kind of notice too, this kind of looks like our normal equation, where instead of the letter P, we're used to seeing y equals, and we'd say 7.5 times x plus 30. Again, that would be a normal function that we would work with. So again, that way if this helps you out writing it like that, you certainly can. But you do want to make sure that you are using the variables that they give. So that means it has to be a letter. So when it's asking for what is the independent variable in this situation, you have to say, okay, well, I have two options. It's going to be one of these two letters, either P or H. Again, since it's an independent variable, it's the one that is measured, meaning it's the one that is controlled. So the amount of hours that she works is the independent variable. It's the one that's going into the function, meaning it's the X value. And that means the total pay, P, is the dependent variable. So then the last part it says, how much money would Letitia make if she worked 7 hours in one day? So that means this. You would let H be 7 in this situation. So that means you would take your input value as H, and you're going to plug it into that original equation. And so now instead of H, we have 7. So I plug it into our equation, and so I say P equals 7.5 times 7 plus 30. Because what this is asking for, it's saying what would be her total pay for 7 hours of work in one day. So we would have to do 7.5 times the number of hours, and then we would include the tips. Again, you would multiply those two together, so we'd say this would be 52.5 plus 30, and then very simply that equals $82.50. So that her total pay for that one day was $82.50. For number 2, it says your school sells lollipops for 50 cents a piece. Let L represent the number of lollipops you buy, and C represent the total cost of the lollipops. Again, make sure you're seeing what the equation would be. So we could say C equals 0.5, so that's our 50 cents, times H. Again, I have parentheses, so that means multiply. And so, my fault, it should be an L, so let's change that. L, there you go. And let's keep it blue, that way it's easier to see. Okay, now we're good. So we're saying this, we're saying our independent variable, meaning the one that is being plugged into the situation, is that number of lollipops. And that's why it's in the place of where the x would be, where the dependent variable, C, is going to be our total cost. And so it's asking, how do we set this up? Well, again, you would say instead of L, we now have 27 lollipops, so we put 27 in that place, and so now then you just multiply it out, and so we could say that would cost $13.50. In the last one, it says for number 3, Shankstone Company charges a flat fee of $87 in addition to the $2.25 per mile. Make sure you're kind of understanding what this is saying. So it's going to be something where it has plus $87, and then since it has $2.25 per mile, I'm going to have to multiply the $2 times the number of miles I have. So then it says, let B represent your bill when you pick up your car, and let M represent the number of miles they towed it. So the equation would kind of look like this. Again, in the place of where our Y would be, we have B for our bill. So that would be the output or the result. And we say B equals 2.25 times M. So we're saying for each mile that we drive, it's $2.25. And then it's plus $87 to start with. So that would mean if we didn't have to tow it any miles, but we do have to get it moved, it would be, $0, or excuse me, 0 miles, but it would still cost $87 regardless. So our independent variable in the situation, again, in the place of where x would be, are M as in miles, and then our dependent variable would be B for the total bill. So it says, if your car breaks down and it needs to be towed at 60 miles, then how much will those Shank boys charge you? So we could put in, instead of M, we now have 60, so we plug it in like this. We would say if we're looking for the cost, meaning the total bill, and so we multiply 2.25 times 60 because that's the amount of miles we have, and so that would equal 135, and then we still have to add that to the flat fee, meaning the initial cost, and so we add those two together to get $222. And then the last part, it says, a separate time your bill is $249. How many miles did Shanks Towing Company carry your car? So in this situation, it's saying this. It's saying, all right, our bill is $249. So you have to let your dependent variable now look like this. So since it gives us the dependent variable, we have to solve for M. So this is just like those two-step equations that we have been doing before. So let's set that up on this right side here. So I have 249, let me move this in, there we go. I have 249 equals 2.25 times M plus 87. Again, we're trying to get that M by itself. We're trying to isolate that variable. So we're trying to get it all alone. So we have to get the constants on the other side. So I had to subtract 87 from both sides. On the right, all we're going to have is that 2.25M. On the left, we do 249 minus 87 is 162. Now we have to manipulate the variable, meaning we have to divide by the coefficient. So we divide both sides by that 2.25. So we do divide both sides by 2.25, and we would get our result as m equals 72. So it says, how many miles did Jenks Towing Company carry your car? If your bill was $249, it would be 72 miles.